jump into our third presentation by Beckhoff Canada's Steve Yardley, who will be talking about reducing mechanical design and commissioning time using intelligent transport systems. Steve, the screen is all yours.
Thanks, Mike and the design engineering team for the opportunity. My presentation will approach this topic in a slightly different way by looking at the specific technology and how this can help streamline the machine building process. By the end of this presentation, I hope to have provided some insight based on a number of real-world application examples. So let's begin. As I mentioned, we're going to be talking about technology and how the next step in intelligent transportation systems, such as XTS from Beckhoff, can help streamline your overall process through design, build, commissioning, and qualification, reducing the time to revenue generation and production with the use of standard proven modules and assemblies, plus how to reduce some of the other challenges found in modern production. Let's start by looking at some of those challenges faced by manufacturing in 2023. Post-pandemic, there's been sustained growth in manufacturing field. Momentum gained emerging from the pandemic has exceeded expectations, and we're seeing a number of different trends. Organizations understand the need to keep up with technology changes and are investing in advanced and emerging technologies to increase agility. Labor continues to be a huge challenge, finding ways to address the labor market to add and retain the right talent. Flexible automation is a key solution to the labor shortage, automating where practical. Recent events have exposed weaknesses in our supply chains. Manufacturing is facing serious productivity challenges as organizations look to address the shortages, in some cases looking to reshoring and local or in-house production solutions. A topic really on trend is smart manufacturing, smart factory, intelligent transportation, the industry of things, and connectivity as the industry continues into Industry 4.0. End users recognize the enormous value of production quality and engineering data acquisition and analysis. A big change is that these end users often now take it upon themselves to undertake the R&D projects and feasibility studies prior to engaging machine builders. So there are many challenges faced by all manufacturers in 2023. Manufacturers will see this as a critical year as they tackle global logistics backlogs and cost pressure, coupled with other concerns due to inflation and the uncertainty of the economy. This list is not exhaustive by any means, but a snapshot of some of the key areas where effective use of advanced and emerging technologies can make a big impact. My goal here today is to demonstrate how deploying intelligent track systems can help solve some of these challenges. So labor shortages. This affects more than just production staff in car plants. We see this in all industries and skill levels, from the service industry and restaurants to our own specialized automation industry. Not only is the labor generally hard to find, skilled labor for mechanical and electrical design, machine builders and programmers are an asset. So it's important to use them for your specialty, custom automation, allowing them to concentrate on the value you have sold your customer, solving the problem that they have. Floor space isn't cheap anywhere, from the physical space to the energy cost per square meter. Optimal use of this valuable resource is critical, especially as organizations consider reshoring. Saving end users floor space saves them money. Consumers are more demanding now, which drives varying production requirements and the need for customization. Small and large batch production combined with a large product mix and varying throughput. IoT, Industry 4.0, the connectivity of things is a hot topic in all industries. Some aspects simpler to implement than others. More and more companies are looking to add digital tools and within manufacturing to a digital twin, a digital representation of a physical object. This can allow users to investigate solutions for manufacturing and process improvements prior to implementation and capital approval. Because of this change in environment, the previous thought process on how to calculate return on investment through taking the asset investment cost and simply dividing the throughput have changed. End users have realized that there's a more complex topic that needs to be looked at, such as the full life cycle and business case of an asset that they invest in. Considering operational costs, which include service and maintenance, not just ROI, are factored into the decision-making process. This results in capital costs not being the primary concern, but the time to market, flexibility, modularity, footprint, and performance all move up the list of priorities, as does the system's ability to be able to collect and analyze the data. Systems that are significantly more flexible and modular inherently carry a level of complexity, so built-in diagnostics and analytics are important. A huge challenge, which is driven by market conditions and consumer behavior, is the ability to adapt and pivot rapidly as the consumer base needs. Product life cycles have become shorter over the last 50 years, and customers' expectations have become higher. So let's start by looking at the steps taken in the manufacturing process when looking to automate assembly lines. The manufacturing process starts with a need, a market demand for something that results in revenue generation and, of course, profit. The next stage is a concept on how this can be met. This will include looking at the product, recommending and implementing any design for automation changes in order to efficiently put this product together. Bespoke automation can be used for many solutions. It's all a matter of return on investment. Once the concept is agreed, after likely many iterations, next comes the final design. Now, the designers, normally mechanical first, have to figure out how to make this concept work, followed by the electrical and software portion of the solution. Most cases, you need a mechanical design or concept in place before that portion can start. After the design is approved, there's a big lag due to purchasing of parts, which is required to happen before build can begin. Bespoke solutions always have bespoke problems, and likely there's going to be on-the-fly engineering changes and challenges which can have an impact on timeline. Once the build is somewhat complete, commissioning and debugging can happen. Ask any software engineer, and they will tell you normally this is a condensed timeline. For an automation sale, after an initial runoff with the customer, the unit will be disassembled in sections, shipped and reinstalled, and once again commissioned on the customer floor. Once the end customer is satisfied that all the parameters laid out during the conception have been met, then production and therefore revenue generation for the end user can begin. Today's market, this needs to be condensed as much as possible. Luxuries of time are limited these days. We'll revisit this again later as we go through the rest of the presentation. Myself, I started in the industry in 1993 as a mechanical design engineer for an automation integrator, and then was lucky to work with Bosch Rexroth, ATS, ABB, and now Beckhoff, with a focus on automated assembly and helping integrators to utilize transfer systems as part of their automation. Typically, the bottleneck is the transportation solution, limited by the best cycle time that can be achieved by using the technology and the process time combined, rather than the takt time, which is more important as it's driven by the customer demand. In many cases, the reason for the focus on cycle time is due to the time it takes to transfer the part between the stations and locate it, rather than the value-added process itself. Cycle time is determined by the process, what can be produced in the given time, plus how long it takes to change over the product, which in many cases is increased due to the limitation of the transportation solution selected. Whereas takt time is based on producing what the customer demands within a given time. To balance cycle and achieve takt in many cases, multiple additional fixtures on a traditional solution are needed. So more tooling, heavier weights, and larger footprints can be the result, meaning the more floor space, more automation, more work in progress, more overall cost. By selecting an intelligent transportation solution, however, the time between stations and processing can be optimized so you're not limited by the slowest process. And there are many forms of transportation to choose from that can be used in manufacturing: dial tables, precision link conveyors, pallet-based systems, plastic chain conveyors, walking beams, and so on. Each of these solutions has its application, but they're very limiting. A dial table, for example, is a fixed process time, one direction, with the slowest process set in the cycle rate. For a modular pallet-based conveyor, the largest challenge is the time it takes to move from one station to the next via different space and time consuming transitions. Then the need to stop and position the part prior to the processing operation to begin. This is all taking up valuable time and space. Each one of these solutions takes time and effort to build and integrate. Both mechanically and electrical design is needed, and in many cases, additional components such as sensors and valves must be added, which someone must figure out how to mount and how to control. This diagram really sums it up. No matter how fast the robots or operators or automation, the limitation is the transportation solution. Traditional solutions often come with traditional problems, but many organizations continue down this path as this is what they've always done. These are the most dangerous words in manufacturing. We've always done it this way. Utilizing new technology such as intelligent transportation systems is the future of manufacturing, the ability to be able to rapidly deploy, adapt to changes in production, volumes, variants, etc., while ensuring maximum OEE with minimum impact on the floor. This is the new way of thinking for many, and I know it can be daunting. I went through this with my transition between a traditional transfer system to intelligent transport system. I've had to adapt and think differently as I believe there's a better way. When you think about your current plans for growth, you're likely seeing similar challenges with how you're currently building. Top of the list items are likely not enough space, product iterations, more SKUs, increased demand, revenue targets, to name only but a few. And the most successful organizations today are those that evolve and understand the new and emerging technology and solutions. So there is a better way, an intelligent servo track system. With this solution, it's possible to simplify the overall automation solution. It's a servo motor with all of the control and precision expected from a servo motor, which means no need for stop gates or locate units, saving transportation time, allowing you to do the value-added process. A modular design allows for reducing planning and build time, plus future-proofing for scaling and redeployment. Having asynchronous ability is a big advantage. Most standard transportation systems, whether it's conveyor, dial, walking beam, etc., move in one direction and are synchronous in operation, meaning each operation takes place one after the other. These limitations often require additional stations in order to balance the line. Asynchronous operation, having control over direction and task, allows optimization of processes and can allow redundant stations to be eliminated given process flexibility. Individual control of each mover helps to reduce the amount of equipment needed because there's no need to stop or locate. Each mover can move forwards and backwards independently. This function can replace an axis of movement, reducing specialized tooling costs. Having the ability to repitch movers is a huge advantage over traditional transportation, which can require standard pitching of equipment based on station design, even where tooling is not required. This eats up valuable floor space. Floor space reduction and process optimization can be achieved by using the repitch functionality. Servo control gives variable velocity and acceleration. Let's remember the bottleneck should not be the transportation system, so you can increase efficiency of stations with fast indexing, which reduces wait time and can reduce duplicate processing and even eliminate some automation. Finally, having available built-in software functionality such as collision avoidance, jerk reduction, automatic accumulation, various motion profiles, easy connectivity via the industrial PC for all major interfaces, insightful diagnostics, simulation capability and visualization simplifies control design, meaning custom code is not needed for these functions. There's a lot of benefits to be had from this one piece of the automation puzzle. Utilizing better automation will allow you to build better automation solutions and help to simplify the overall investment and implementation time. Making a comparison between synchronous and asynchronous motion. Dial tables generally operate in a synchronous motion. Stations on a dial must be at a fixed pitch, fixed speed, fixed direction. This means that the overall cycle time is driven by the slowest process. If you multiply the slow stations to aid cycle time reduction, then the knock-on effect is each set of tooling must pass through each station and wait whether it needs to be worked on or not for the duration of the cycle time. This can also mean unneeded additional tooling, duplicate stations, blank stations, extra floor space, extra cost. Asynchronous motion enables higher throughput and flexibility. Intelligent transportation systems can operate asynchronously, synchronously, or a combination of both, which is determined by the application process. Here we can see where the solution was realized by utilizing the mover's individual control and ability to repitch as required by the process. So going from 1 up to 2 up to 5 up, and then back to similar pitch sizes as dictated by the process and the cycle time requirement. Servo motion allows full configuration of velocity and acceleration. High velocity and acceleration means reduced transportation time. While low acceleration can help for sensitive and unstable or fluid parts, low acceleration and low velocity could be used for a curing station, for example. This enables high overall machine throughput. All of these capabilities and features allow huge reductions in custom engineering, design, and custom code writing, allowing the specialists on the team to concentrate on the areas where their skills for creating custom equipment is best used, rather than on the basics of transportation, which is used to connect these islands of automation. Bidirectional nature of a servo motor allows not only for speed and acceleration control, but also direction. So you're free to use the mover as an additional axis, saving on automation and complexity cost. An example here, a print head. Having the ability to send the mover backwards and forwards allowed this customer to define the exact number of passes required in this printing process. This was only using the feedback from the system XTS. No additional reference measuring system was needed, or any additional servo axis were required. This saved space and also capital cost. So let's talk about floor space. There's a demand for production facilities to make a variety of different products and to switch between them more often. It's not typical to make tens of millions of the exact same product these days. Batch sizes are reducing, form factors are changing, packaging materials and methods are changing, and it's not practical or possible to build a new factory for every new product. Expanding production facilities is expensive and not always possible. Land purchasing, zoning, permitting, construction, it all costs time and money, and there may not even be any space to be able to expand. Getting more production out of existing factories is critical and a lot less expensive. With technologies like XDS, we can pack more production into a smaller space. We can look here at a user case. There was a need to expand the production capacity of an existing machine. But there were several hindrances. So there's warehouses, pillars, escape routes, things that either can't or are difficult to move. A more efficient new machine was sought to give more flexibility, having the ability to produce different product formats with one system and to increase throughput. This would give the end user an increase in revenue per square meter. For building often become a challenge when installing new equipment. Traditional solutions used up way too much floor space, had too much wasted motion, and weren't flexible enough for the customer needs. Having a transportation system with modular building blocks for straight and curves with inside and outside geometries offers huge flexibility of layouts, ensuring any challenging features such as the building columns can be designed around and the available space maximized. This line was designed to fit in the space available, and because of the features of this solution, stations could be positioned on corners and equipment placed in the center of the line to maximize space. Intralogistics was incorporated by linking stations 1 and 10 directly to the warehouse, and this was running various product types. The stations highlighted in red would be enabled or disabled based on the production demands. For example, the products being produced may be similar in design, but with some slight differences or customization. So variant 1 must pass through all stations. Variant 2 only needs to visit 7 of the 10 stations, and so on. It's possible to have these different variants running on the line at the same time and not impact the functionality, giving the customer maximum production flexibility, enabling them to use their capacity as desired. Adding a vision inspection station between station 6 and 7 was also possible with minimum floor space and cycle time impact due to the ability to inspect on the fly. Let's look at a customer example and installation. Geffersoft makes diffusers for airbags, a safety critical part for your vehicle. They deployed an XDS for optical inspection. This optical camera inspection is slow. 11 individual processing stations examine these critical parts down to the micrometer level. Individual motion of the movers allows for multiple individual test processes to happen in parallel, meaning the throughput is no longer determined by the time-intensive optical process, so the faster test stations can be used sequentially, allowing optimal utilization of the assets. As a result, the 2-second cycle time requested by the customer is reduced. The optimization of the stations also enabled a reduction in stations needed to the machine acquisition cost, and floor space were both reduced as a result. In this case, the floor space was reduced by 40%. The high speed and position accuracy of the XTS system even allowed for some additional capacity to be available, which can be used for future expansion for any additional inspection tests or to further reduce the throughput and therefore adding security to the investment made. A modular system will allow mechanical designers to create the layout demanded by the application environment, not by the limitations of the equipment. Not only do you have to consider each process, as we just saw, the available space and objects such as pillars impact layout. We've already observed a straight line doesn't always work. Having the ability to configure the track as you require based on the floor space is key. XTS is a great example of this, using a small number of modules to build up your system, starting with the straight and curved modules with different rail solutions depending on payload, complete with matched movers. This solution is completed with an industrial PC utilizing TwinCap. This control system, based on an IPC with simple connectivity, rounds out a user-friendly modular system. Modularity helps enable pre-assembly, which offers more time savings. Modularity also allows for easy replication. This can be a huge advantage for an organization with a global footprint. As we know from the reshoring trend, it's often more cost-effective for end users to manufacture locally to the market they serve. Let's see an example. Modularity and flexibility were two of the key aspects for L'Oréal selecting Beckhoff and the XTS system for their F24 production line, which was realized by French integrator SICAP. This line was used to produce over 55 different variants of foundation, having bottles of different types and shapes, plus having many different styles and colors of product. The ability to switch production in seconds based on the customer demand was critical. This system replaced 5 of the machines and gave floor space savings of over 30%. L'Oréal, being an international organization with manufacturing globally, saw that the modularity and standard design from a proven solution available globally gave them the ability to replicate this in other countries to suit their local needs. This system was 22 meters long with 40 movers. It performed several different tasks, including bottle infeed, filling, attaching the pump, cap and label, with full transparency over the quality of the product. This solution fitted L'Oréal's vision of innovation and quality and increased their flexibility in production. Beckhoff then makes your life even easier. Taking time to understand your needs, we build on modularity with a proven plug-and-play solution which enables simple and fast project implementation. We pre-assemble and test this system for you, which then reduces potential sources of error and simplifies project coordination. Using this proven solution, which has been deployed more than 2,400 times in the last 10 years in a wide variety of industries, enables users to piggyback on the experience and risk reduction, given the ability to calculate costs thanks to an easy integrated overall solution. The benefit is that this allows you to utilize your labor and other resources in your specialized areas of expertise. Here we can see an example that was pre-assembled and tested for a customer in the pharmaceutical industry. It's a large system. This is only part of the entire line. One machine with 15 XTS systems and over 400 meters of track, complete with over 1,500 movers. The simple and fast project implementation reduced potential sources of error and allowed the customer to work in parallel on their custom automation. The customer provided the base frame structure details, which was designed around a combination of the transportation solution and overall machine design. Consultation ensured all ship and breaks were exactly as desired. Mechanical assembly, complete electrical cabinets, functional testing prior to shipment gave the customer the ability to work in parallel, knowing once the transportation system arrived, it would fit and function as expected, speeding up the overall implementation time. Could it be even simpler? Of course. A modular concept with the ability to adapt quickly as manufacturing changes. Giving an organization ultimate agility, this concept uses the emerging technology of planar technology. Having 6 degrees of freedom and utilizing modular tiles that are used to create a path which the movers can travel on. Adaptation and alteration is quick and simple as needs change. Literally throw down tiles where you need the movers. It's simple. This is tomorrow's technology today. And this isn't just futuristic technology. It's being used right now as part of our own production for bus terminals. This is part of a critical production process as these products make up a large percentage of Beckhoff's annual revenue. The explainer is used to link stations. Starting with picking from a tray, the camera identifies the serial number. The mover is then sent to the programming station and the specific program is flashed based on the serial number. It then goes directly to the test station. The 2D movement allows decoupling of flow, so if longer test cycle is required, it doesn't affect the other modules in production. Having 6 degrees of freedom, explainer replaces the need for additional handling units, such as when handing over to the test cell, the vertical movement of explainer performs this function, so an additional axis or robotic device is not required. Let's talk about some digital tools and IoT on a really high level. Specifically for automation, digital twins can be used to improve production and process and are being used in all types of industries to help enhance complex projects. Digital twins, which are a digital representation of a physical object, are exceptionally helpful for simulating manufacturing lines in the development stage to help support development of production systems. This helps to shorten time to production, increase flexibility, aids optimization and performance improvement. Being able to change the individual mover's acceleration and velocity paired with the ability to repitch on the fly to adjust then process flexibility in your manufacturing. The digital twin is then further used for virtual commissioning, which can occur in parallel with other operations during the manufacturing process, ensuring your selected system has a solid control platform base, complete with the right tools is critical for success. For example, digital tools made available by Beckhoff's TwinCat running on an industrial PC include project planning tools, which allow you to check many issues without a single piece of hardware: sequential control, power consumption, production rates, bottlenecks, and so much more. Integrated XTS simulation functions also facilitate plant design. They enable the user to assemble any desired track layout from the XTS modular system, to check the subsequent integration into plant concepts, and to verify application sequences. During the development process, all parameters such as track layout, number of movers can be adjusted as desired until the optimal solution is obtained. The generated program code can then be reused for the physical hardware. This significantly speeds up the plant design, configuration, commissioning, and reduces the time to market. This is an example of how Beckhoff simplifies the project planning of XTS applications with a software toolkit already included with a range of functions. A tool window summarizes all components in a clear display and is in the central point for the user to be able to complete with all the different functions. Using the configurator and software builder, the user is guided through the setup of parameters for the application with visual support. After only a few minutes, you can see the movers starting to go around the system, either on the hardware or in simulation itself. Thanks to the integrated live view, it's easy to visualize the entire system and to understand the programming sequences and movements of each mover, and they can be observed in real time on a display. The user doesn't even have to be near the equipment. Included motion function blocks reduce engineering work depending on the application. Different motion profiles may be required, from a simple linear movement to highly complex sequences. The mover behaving like a servo in engineering starts to really show its advantage. All established motion control functions can be used, plus other function extensions like automatic collision avoidance, simplifies synchronization of movements, the use of physical shifted track layouts, and other special features. All of this with built-in diagnostic functions. Errors can be rectified promptly and quickly, and error messages are directly available to the viewer. Having an industrial PC-based control offers several benefits, such as reduction of cabinet space, typically by 50%, less panel space by 40%, and less cabling is needed when deployment of Beckhoff's IPCs with EtherCAT. There's a reduction of integration time, debugging, reduced complexity, and reduction of labor doing repetitive tasks. Everything is designed for reduction, either in physical space or time to design, assemble, and debug. This simplifies the integration of PLC, motion, HMI, safety, measurement, vision, and IoT, all by using one software on one CPU. There are many options of IPC to suit the application based on the complexity, how many cores are required, with the options of embedded, panel PCs, or HMIs. Being a PC, all interfaces are available for additional ease of integration and connectivity, such as EtherCAT, Ethernet. PC-based control means data is available centrally, such as diagnostics, predictive maintenance, giving real-time coupling between the process and hardware. Being a PC, it certainly makes it easy to connect and address the IoT challenges. So we've explored, by looking at some real-world examples, how intelligent track solutions can help with a number of these challenges. Labor is addressed in several ways. In design utilization, the modularity of the design and software functions, such as simulation and virtual commissioning, and then also for the end user through optimization of processes, help to ensure labor is deployed where it's best used. Floor space constraints are first addressed by using the building block modularity, fitting the solution to the available space and required automation, and then optimized once again with simulation, hitting production rates with the right sized solution. Individual control and process flexibility allows the end user to customize their solution based on changing requirements. Correct selection and easy adaptation and connection of the right IoT tools for your organization and your end users make integration and diagnostics easy. Having a solution which is really easy to reconfigure both mechanically and with software ensures your end user's ability to pivot and be agile as the market demands. All of these help to solve a complex puzzle. What you've seen in this brief presentation is an intelligent transportation solution that's fast, agile, modular, and flexible. As you've seen from the examples used in various industries such as life sciences, automotive, food and beverage, consumer packaging, delivering value to several of the challenges end users are facing. The sweet spot is, but not limited to, complex, high volume assembly with a wide mix of products and or a wide mix of processes. These days, end users often take it upon themselves to undertake R&D projects and feasibility studies prior to engaging machine builders. This means in many cases, they're already exploring and understanding the benefits of intelligent transportation solutions directly. Utilizing this as a platform for your automation maximizes throughput while minimizing the impact on the factory floor. Production versatility and adaptability are key areas for a successful business model, and we're here to help you with that journey. We saw this earlier, and we have seen some great ways of how using intelligent track systems can increase efficiencies through this process. More and more, we see the service life of machines getting shorter, faster to market being more important. So we have to find a way of shortening the phases in this process and allowing them to be worked on in parallel to reach revenue generation faster. As you've seen demonstrated here, using intelligent track systems, it increases efficiencies through all stages of this process by understanding the manufacturing processes and impact of each one through simulation ensures optimization and will highlight any potential problem areas to address prior to deployment. These intelligent track systems are already a proven solution from a mechanical fit and finish through to electrical items and software. It's already been done. It's a proven working solution, so debugging during commissioning is vastly reduced. Even during this phase, there are virtual commissioning tools and insightful diagnostics. Modern production requires modern solutions, and this is one solution. Employing evolving next generation technology with unique innovations and insightful tools to help with each stage process reduction and cycle time reduction through individual shuttle control, being able to conduct the process in parallel with the standard building block design of the track system and digital tools within the control system. Broader diversity of products means that some traditional manufacturing processes and solutions may not be the best way to secure the investment for future diversification. In today's environment, you need to ensure that you can be agile enough to adapt to the market and the customer changes, given security of your investment. Investment in the right technology solution, which is adaptable to varying products and volumes, gives clear return on investment. So again, thank you, Design Engineering Magazine, for allowing Beckhoff this opportunity to share some thoughts on this topic. I hope the user cases have demonstrated how deploying intelligent transportation systems such as XTS from Beckhoff can benefit your operation and help not only improve your revenue, but also agility. The goal of this was to be informative and an introduction to intelligent transportation systems, allowing you to go away with some new ideas on how you can provide even more value to your customer base and how to stand out from the competition. Everyone here at Beckhoff is here to help you succeed. Thanks, Mike.
Thank you, Steve. That was great. I learn something new every time I hear or read or research this topic. Can you speak to how precise the individual movers are?
Yeah, the repeatability is plus or minus 10 micron. Positioning accuracy is about plus or minus 0.15 millimeters.
That's amazing. They're more like flat robots in a way that happen to move things from station to station. That's the way I've begun to think about them. It's
a servo motor that's been unwound.
Yeah,
that's the easiest way. So basically, you've got a servo motor. You've got all of the control aspects of and flexibility that you would expect with a servo motor.
Sure. Is there a way of all the demonstrations that you showed were single tracks and in many different configurations, sometimes an oval, sometimes a circle, sometimes serpentine. Is there a way of having an A and a B sort of channel? Like, is there a way to have different multiple routes through the same circuit, or to connect multiple circuits so that things can be diverted one path or another, depending?
You could definitely hand off products from one track to another, but in many cases, especially with how the products are designed these days, the products are similar to each other, right? So maybe it's just a slight difference. So in many cases, you can have that one example that I gave, where you've say got 10 stations, but product variant A only has to go through 8. Product variant B has to go through 6 stations, and so on. So basically, it just ignores the stations that it doesn't need to go through, and then can continue through that path. But yeah, there's certainly another way of you can do a handoff, which would maybe by using an additional axis. Gotcha.
And there are little elevators. Isn't there like a module that's like an elevator?
Yeah, so yeah, we have a track management system as well. We work with HEPCO on the guide system, and we also have a track management system. So yeah, we can do multiple different lanes.
Gotcha. Or different tracks and different orientations working in conjunction with each other.
Exactly.
You showed how TwinCat helps with, or special software within the handles programming the individual movers and how they'll work. But I think the really powerful part of this is how the conveyance system becomes part of the tooling almost, given that repeatability that you mentioned. How does it interface with the other stations? Like, I see how it's programmed within itself, but the coordinating motion between two.
Program is actually used. You can use that to control the whole system. So there's no need for any additional PLCs. Yeah, the IPC with TwinCat on there, you've basically got an IPC with a PLC on there as well. So that can control the complete system. Whereas, you know, some of the other ones on the market, they have their own black box controller and then will interface to, you know, whoever else's PLC it might be. Here, you know, there's an additional saving that you don't have to have that additional PLC. You've already got it with the system. I mean, obviously, if somebody insists that they need, you know, a specific brand of PLC, that's also not a problem. You know, we can communicate over all of the normal bus systems to be able to transfer the information.
Gotcha. And I imagine being PC based, it exposes whatever information might be interested in an IoT sort of integration stuff. That can go to a PLC and then up the stack as needed.
Exactly. You know, the easiest way to connect to IoT is by using a PC, right? So when your control system is based on an industrial PC, you know, Beckhoff has been basically doing IoT since 1980, right?
Mm-hmm. Can you talk a little bit about no cable technology? How does that integrate? Is that a new thing?
Yeah, that's a new product which we're hoping will be released by the end of the year, which is kind of playing on the screen right now. So it's the ability to basically have some sort of power on the mover itself, whether that be vacuum or electrical, etc., without having to have, you know, any cables connected to it either. So it's going to really revolutionize the way that people can do applications.
Okay. I just so I understand how does it, the power is done wirelessly? Is that?
Yes. Correct, yeah.
Okay. Great. And there are multiple variants, right? There's a black version and there's a stainless steel version and there's
depending on the application, we have a couple of different guide systems depending on the payload. But then we also have a clean version of the system as well, so we can go to IP69K. So we can go into, you know, some of the washed down versions of the system too. Gotcha.
Great. Okay. Well, that is all the questions that we had for today, and I'd like to thank you again, Steve, for a great presentation on this.
You're welcome.